Be sure to check out this segment where Chris Vizas of SmartSenseCom and Bruce Walker of the Analysis and Resilience Center for Systemic Risk discuss the power grid's complexity and the need to modernize this aging engineering marvel.
You see the evidence of that and what's already happened in telecommunications and in the the networked IT world. And frankly, for better or worse, the paradigms that we're all working with are paradigms that came out of the evolution of telecom. The fundamental difference is that telecommunications, beginning in the 1920s and 30s, built into its network infrastructure and into the equipment in the network, the ability to communicate with that equipment, and for that equipment to report on what was happening on a network-wide basis. And that's only beginning to emerge in for example, in electric power. That network-centric view of the world and structure of how you approach your problems is just beginning to emerge in power. And it's something you have to learn, and it's something that you have to develop and implement the equipment that allows you to do that. For example, in the 1970s and early 80s, when you were changing over entirely to electronic switching and software-based switching in telecom, there were ways to make inquiries to the machines, to the switches throughout the network that were built into the equipment because of what had gone before. That's only beginning to happen now in power. And you're going to need that to happen. I mean, people talk about, the smart grid, we're going to be able to do this, there's that kind of, the answer is you're only going to get to a world of automated control and automated alarms that are grid-wide once you have upgraded the equipment. It's not necessarily upgrading equipment, but it's putting in devices that allow you to know what the equipment is doing. Sometimes you don't need to change the equipment. Our kind of approach at SmartSense, for example, would say you don't change the equipment, you just put in sensors that can tell you what the equipment is doing.
I'd like to build on some of what Chris actually said, because one of the things that I did initiate when I was at the Department of Energy was the development of a North American energy resilience model. And that model is really the operationalization that Chris mentioned, wherein we were taking the system writ large at a North American scale and looking at ways to model it so that we could provide situational awareness, particularly against things like cyber physical threat or any other anomalies on the system. And what that really requires, as Chris noted, is the ability to censor the network, if you will, writ large. Much like after the 2003 blackout, where you saw this utilization of phaser measurement units, so too now with the North American Energy Resilience Model, you've got to enable and provide sensing in the system that will give you that situational awareness to identify anomalous behavior, whether it's harmonics on a system that are being introduced by things like inverter-based generation, whether it's other electronic devices being able to pick that up. And one of the key areas was the development of collaborative cyberware sensors, right? So you start coordinating the physical phenomena, which I think Chris is the sensing capability he's talking about. You take that electric phenomena, the physical phenomena of the world, and you start correlating it with some of the threat vectors and vulnerabilities that are on the system. And you start getting this very sophisticated picture of the entire situation, right? And recognizing the interconnectedness of the systems, and the sensitivity of the system, having that forward look enables that ability. I will tell you, one of the things that we did in development of the North American Energy Resilience Model, with that, so too did we initiate a sensor technology and data analytics standalone program within my office to really move forward on technologies like Chris is talking about that have that real high fidelity high throughput capability that can get into sub-cycle range capabilities of monitoring AC/DC anomalies for things like harmonics or geomagnetically induced currents. So there's a lot of capability, and when you then bring that down into a city type analysis, like you're leading, Pete, the opportunities really are they're layered, right? So the better information we have, the better our capability to process it and understand from a modeling perspective what the potential impacts are. Therefore, you can take that information and continually improve the system's capability. In addition to the aging component, it's really the increasing complexity of the system and this transition specifically from a large core generation pushing to this very dispersed and different types of generation that actually have kind of variable paths of supplying energy, right? So all of those things help drive the need for different capabilities that I think you were going to pivot to Chris and talk about, but we've got a rapidly changing system as well.
If you like what you heard, be sure to tune in for the full-length interview on March 25th at 11 a.m. Eastern Standard Time. Go to dotsandbridges.com for more information and be sure to subscribe to our YouTube channel.